Hello students, welcome to EduCell. In this video, we are going to discuss about Prim's algorithm. Those who are new to this video, kindly watch the introduction of the MST as well as the introduction of spanning tree that is there in our introductory video. And before that also, if you want to check the crucial video, it's already uploaded. So you kindly visit that one. Now in Prim's algorithm, what we have to do, first of all, I'll tell you, I got this information from Corman book. Okay, the book name is Introduction to Algorithm. Kindly read that one if you're not able to understand. This video I'm trying to give you certain things which could be easy for you to understand the algorithm. Okay, let us start. MST Prim is a function through which we are giving G as a graph name. Okay, W is weight, and R we are just considering a variable where we're keeping the keys. Okay, so keys are not a different thing here. We are just collecting the information about such node. Okay, so our target is the the value of the node. Okay, though we know the weight is something like which we can assign as the weight of the AUC is being decided or might be written in such a way, W of U comma V, the source, or you can say UV is there are two different nodes through which an age is getting detected, and W represents the cost of it or weight of it. Okay. Now it's written, the for loop is written where we are actually collecting the vertices. Okay, the number of vertices are there, we are just collecting it. You can simply write this one, which the side I can say this is also pseudocode, but this is just understanding point of view. I have written the theme, I just kept the theme in such a way that it would be easy to understand what is written there. Clear? So we are actually collecting vertices. Next, the key. The first point is the the key of it means the value in initially we is decided as infinity for all the nodes or for all the vertices. Next, this pi. If you are new to this video again, the previous video we have already discussed in heap cases, like the parent or the predecessors means the previous one. The like the previous one will be said. Suppose this type of graph is written. Clear now? So predecessors of B or pi of B would be A. Okay. So to represent that one, we are just saying for the first time, though we are running it, the key value we decided as the infinity, and next value we said as nil. Okay. So no predecessors are there. So we decided for it first. Next, the value we started with 0. Those which one is selected as suppose the source one, so anything could be selected as source vertex. So to start with a source vertex, the value will be 0 or the key would be set as 0. It's also written here. I am just reading that one for the to what extent that I've simplified. Here it is the same thing is written. Create MST set. Okay, that keeps track of vertices already included in MST. Okay, what are the vertices that we are actually trying to include? That MST, we are just storing that one, and what we are doing, assigning the value of all the vertex indices in our input graph. Initialize all the values as infinity. Infinity is not a term really existing. You can say a bigger value we are actually in data structure point of view. You can say it's a bigger value. A bigger value means you can say like this, a bigger value we are just introducing as infinity. Okay, next thing is assign key value like 0 for the first vertex so that it is picked first, means whenever we are selecting, the first would be starting from 0. This is the approach for a greedy algorithm, or might be the steps for selecting greedy point, but still we are not exactly reading the greedy. Whenever we the video, like when a digester will end, we'll discuss what is greedy then only we will discuss more and more details about it. Now, in q equal to g dot b, we are actually uh, storing again the vertices in a queue. So here for that one it is written we started with while. So here you can say, so once up to q we store everything. Doesn't include all the vertices means until it is empty. That means until it is empty, we will run the u with pick the extract mean function. It's a priority queue basically. Okay, so it will keep the minimum first. Okay, the minimum will be selected first. This is a use of priority queue. Okay, next for all the vertices for each v, small v we are going to introduce now, belongs to g dot adjacent of u. Clear? Those which are adjacent to the small v, like the g, which are we are actually keeping the adjacent vertices. Don't worry, we will be discussing the same example in the book with the steps which I will write for you. That could be remembered, not an issue, but still the the algorithm should be understood well. Next, if condition we set the q is already keeping the vertices. Okay, the v is adjacent to the u are actually keeping in a set. Okay, that belongs to if condition, like there are two different conditions we have written where small v belongs to the all the vertices which we collected, and here the value or the key you can say should be greater than the cost of the age. Then only what we have to do, we have to select that one. How? We have to say the predecessor will be u if we are selecting v, as well as the key value will be updated as the cost of the age. Okay, so as per this it will run, though it's a for loop that I know uh, you don't know how to find the time complexity. If you do not know, the detailed video is also there. The for loop we are running for v times, so you can say it is running for v times. Now it will check until it is empty, though we are using priority queue. So we must say if you are running priority queue, okay, I'm just writing in pq, the time complexity could be big of v e log v. This is what the answers we can expect if you're not using priority queue. Suppose not pq, the answer could be v square. Clear? So or you can say big of n square also, where n is a vertex and v is also vertex. Okay, so this is what we right now have studied. Here the points have been written in such a way that it could be easy for you to understand. Now we'll go to our steps. Okay, so whenever we are running the steps for Prim's algorithm, always keep in mind, though we in a critical approach we are keeping in ascending order. Okay, the in a tabular manner, first of all we are keeping all the edges with the cost in an ascending order, which will be very much easy for us to select the minimum first, because as per the greedy approach, greedy will only pick the minimum if the ultimatum, if the function or if the desired output will be minimum or optimized, then only we are selecting minimum. Suppose in that case you can say maximum elements will be picked first, means from maximum onwards we are trying to pick the elements. Now for the step one, so here you just remember, I'm writing here, that could be better now. Okay, start from any node. यहाँ पे what exactly we are doing, we are selecting from the nodes. That time we are selecting from the edge. Okay, so you can select any node, any vertex as source vertex. Clear? Next, once you have selected, here as per the example, this is example of Corman book. Okay, you can check it. In a Corman it is written A, B, C up to I. There are the procedures have been written. Just check it. As per my steps, what exactly I am writing. First, selecting any vertex, or else you can start with the A is also not an issue. So once, try to remember well. If you're selecting this, so you have two options. Okay, the minimum will be selected, though you are using here in this approach, you are selecting this extract min, whichever the connected thing will be selected first. Okay, so here from A, only one option is A. From A, we have two options, like two connected, connected links have been there. Out of these two, so 4 is minimum for us. Then you can select that edge. So you can say the minimum cost or weight of the selected vertex will be picked. Okay, then 3, repeat step 2 until, before that at least we should uh, clearly write if the selected edge will not creating or making any cycle. Next is repeat step 2 until all vertices have been covered or have covered. Clear? At the end, what you have to do, you have to add the cost, then you'll get the answer. Okay. First, select any vertex as the source vertex. You select that one. So as for the example, we have selected it. Don't worry, this is the example. First, in detailed lecture video, we are going to discuss on the book what is there in a book. Next, in a problem solving video, as the channel is dedicated for the education, here the course we have fixed is algorithm now. So for all the courses, the upcoming classes, upcoming lecture videos are also coming on different topics. So the algorithm or any topics, the first target is we have to focus on the detailed lecture video first. Then as per the R steps, we focus on the problem solving videos. Okay. So first we have to select any vertex as source vertex that we have done. Next, minimum cost or weight of the selected vertex which you have already selected. The minimum cost or weight of the selected vertex will be picked on the basis of what? If it is not creating any cycle, then only we will pick that one. Okay, I'm just changing the color here. You can check. We will, if it is not making any cycle, if it is not making any cycle, we will pick, otherwise we will not pick it, and we will repeat until all have been covered. Okay, so any vertex we will pick as a source vertex. Don't worry about it, but you have to keep in mind, you have to check the connected one. Now you check, as per this we have selected this A to B. Okay, now we have two options. The two vertices have been entered. Now we have two options. Okay, एक बार हम start कर लिए ना, whenever we are picking one, the next one from there we have two options. जो minimum है that will pick. Whenever we are finding any minimum connected to list, so only based on connection we are working. Okay, we are not going any disconnection, or might be which is not connected, will start from it. Prims is based on the connected one. Okay, next, here there are options. B is selected and A is selected now. So from this there are three options because these are connected edges. Connected edges will be selected first. Okay, so it's written, if you can say minimum wage or selected vertex will be picked. Okay, will not create any cycle. Next, out of this 8, 11, 8, there are two options. We can say 11 is greater, so we have two options, either or will be selected. As for the book, they have selected 8. Now we have three options. Out of these three options we have to pick the minimum one. Here you can check the probability is either you can pick 8, you can pick 11, you can pick from C 2, 4 and 7. So out of these five options the minimum is this one. That is why we will pick this, pick the C to I. Okay, here you can check C to I. Okay, now from here we are having four options. From this four options the connected edges will be selected first. So the connected edge you can say, this has already been done, 1, 2, 3, 4 and 5. Out of this select we have to select the minimum one. Here 6 could be selected, or 4, here this one also be there. So 4, 6, 7, 11 and 7. So out of this 4 will be the smallest. Now 4 we have to be picked for the next time. Yes, here in E it is being there. So we have now visited, there are 5 nodes. From 5 nodes almost we have the options for this 2, 6, 1, sorry, 7, 11, 8, 10. So out of this, so lowest is 2, that will be selected now. Okay, so now whenever you are selecting this one, so you are indirectly covering the vertices, which are the connected edge that you are keeping in mind, and we are just covering the vertex. So here we have covered it. Now we have options. So as for this option, the minimum will be found out as 1. So next, here we have selected this one. So whenever we have selected this, we have to find out again the smallest one which is connected. We cannot pick, here you can check 6, 7, 11, 8 and 14, 7, this, or within that the 6 is minimum. If I'll pick this, it will create a cycle. That is why we have to remove that one for a while. And if you pick 7, next element, next increment operator, or sorry, next incremented value will be 7. So here if I'll keep 7, it will create a cycle. That's why I need to remove this 7. And then we have again 8, 11, 7, 14, 10. So out of this 10, 7 will be the minimum, and if I'll keep this one, no cycle would be maintained or formed. That is why I can say I can pick this 7. Okay, so now we have to check from the selected node, the connected edge will be picked first. Here 9, 8, we have to discard. Why? Because if I'll keep this one, it will create a cycle. That's why I need to discard. 11 is there, and then 9, 10. So out of this 14 also there. So 11, 14, 10 and 9. 9 will be the less. So that's why we have kept this one. Once we have kept it, based on that we can say we have done the find out of the MST. So the cost would be same whether you can find through Crucial or you can find through Prims also. The cost would be cost of the MST would be like 4 plus 8 plus 7 plus 9 plus 2 plus 4 plus 2 plus 1. Okay, From this you can say it's 10, 4, 4, 8, 10. Okay, now it's 10, it's total 37. As we recently got the answer as 37 in using Kruskal also. So 37 will be the minimum cost we can expect, and this is because this is done because of the greedy approach. The minimum will be selected first, or the maximum will be selected first, without thinking whether any problem will occur or not. We are just picking the minimum one. So this is how the approach is running, through which you can run the prims. But the note what we have to write is, what we have to remember, whenever you are focusing on Prim's approach or Prim's algorithm, it will focus on connected connected edges. Clear, no? Connected edges will be selected first. Connected edges of the selected vertex or vertices will be checked first. So connected edges only. Here in Kruskal is no connected, or you can say disconnected edges. We are performing the work on disconnected edges, but in an increasing order. This is the difference. And here the complexity we discussed, and I hope it's clearly understood by you. If any doubt, you definitely comment below. So thank you for watching this video. Have a good day.